welcome to everyone for this new episode in our series of EC webinars on game changers. And this particular series, for those who are new to it, focuses on risks associated with space environment. So we heard about extreme events, climate, carbon footprint, and today it will be something quite different because first of all, because our speaker is not someone who is from the scientific committee as usual. Klaus Sievers is a pilot who has spent most of his life, as you can imagine, flying aircraft for Lufthansa. He has been pilots of Boeing 747, and he has played an instrumental role in alerting pilots and playing at the interface of what his company wishes to have and the scientific aspects. What is the vision on weather? What are the risks? And he has represented different bodies, which he will present later on. So for us, it is a real pleasure to have someone who is going to talk and to bring up the inside story from a user who is directly confronted to these risks associated with the space environment. So I'm Thierry de Witt, as usual. I'll be your host for this series. If you have questions, please write them down in the chat. And after the talk, I'll be collecting the questions that are similar. And if not, there will also be a possibility to ask them there directly. So if you have burning questions, please keep them in the chat, and we'll have ample time for discussion at the end of the presentation. Let me just mention that this will be the last presentation of the year, and we continue next year in January. That will be on January 16, if I'm right, or 12. Sorry, I mix up the dates, but not the first week of January. And we will continue with different presentations on Auroras, planetary exploration, artificial intelligence for space weather, and so on. So with this, I give the word back to welcome among us, and the floor is yours.
All right, thank you very much, Thierry, and heartily welcome to everyone here. Good morning, good evening, good afternoon, whatever it may be. And yeah, first of all, I'd like to thank also ICI, the Space Institute here, for having me today. I've been a pilot for a long time, as you might have seen in my CV, and the last 6-7 years I have concentrated on weather after retirement. That's a very nice, interesting field to go to. And I found space weather and volcanoes, volcanic clouds, very fascinating. Today it's about space weather, auroras to GPS. I'd like to point out that I'm active on behalf of IFALPA, that's the International Federation of Airline Pilots Associations. We represent the about 100 member associations, that's countries, organizations, and more than 100,000 airline pilots. We have a presence, headquarters in Montreal, which is close to ICAO, where the aviation rules are made for the world. So today I'd like to address the question if space weather impacts aviation. I'd like to introduce information available from the American Space Weather Prediction Center and ESA. I'll be talking about the ICAO space weather advisories. We will go through a little bit of science for space weather on 7th of November 2022. That's not so long ago, actually. And I will go through an example of how pilots might be influenced by space weather. Space weather. This is how pilots actually see it. When you do night flights over the Atlantic, over other high latitude areas like the Russian Federation or in the Far East over Alaska, you can't escape it. You will see the aurora. And that's a very fascinating aspect of space weather. I will mention that again later. So let's just go on to the next picture. This one here is from ESA. And as you see, it actually puts an airplane at the center, which is very nice of ESA. But it also points out the influences from space. We have in the left corner, we have the cosmic rays that are coming from other galaxies or faraway places, and which are coming at a rather constant level. However, they can have high energy, can cause radiation damage in satellites, can cause the same in aircraft electronics. Of course, it's very rare, but we will see. And then we have the sun, which is here in the center. It can give us solar flare radiation, which disturbs the layers of the ionosphere. And the sun can also produce mass ejections and send high energy particles towards Earth. These high energy particles would then increase the radiation that people have who fly. The ionosphere, it's a layer of ionized gases, let's say 100 kilometers up, and the influence is pronounced on shortwave radio signals, which you see symbolized here. Satellite receptions can be disturbed by it, and then we have the effects of geomagnetic storms on induced power. That's an overview, and now let's go through some more in detail to answer the question about space weather and if it influences aviation. Of course it does. I mentioned high energy particles, that they can affect electronics. One such event happened in 2010. An aircraft was flying very nicely and then suddenly the nose dropped. The autopilot did it, and before the pilots could recover the situation, they lost a good deal of altitude and 100 passengers were injured. They landed somewhere nearby, so the people could be taken care of. Investigation report by the Australian government was not super clear, but they suspected a single event effect upon the electronics. One system they suspected was the inertial reference unit. That is like a gimbal gyroscope that gives attitude information to the electronics that maintain the position of the aircraft in space, in the airspace. So if that's wrong, then anything can happen. Not a good situation. After this case, EASA tightened the requirements for resistance of electronics towards single event effects. And just 2 years ago, I think they issued an update. Then we have the satellites that are flying in outer space and providing all kinds of services to aviation. We communicate via satellite when flying over the oceans. We have navigation, of course, GPS and other similar systems, related systems. And we also have surveillance via satellite. That would be the Aviation system, where position reports are automatically sent via satellite. So satellites are a key resource for aviation. And sometimes the space environment seems to be unfavorable, and internal and surface charging can occur. And then in this case, a navigation satellite providing navigation services besides communication services couldn't work anymore and was out of commission for a month or two. Now, closer to home, closer to Europe, in 2015, there was a big commotion in Sweden, southern Sweden, because the airspace was closed. why was the airspace closed? And my daughter told me the next day, hey, Papa, you know something about the sun, huh? I know, yeah. You tell me why. And so I sat down and went through all the usual suspects, but couldn't find anything. There was no special disturbance in the geomagnetic parameters or in the layers, the various layers of the ionosphere. And going through newspapers and internet reports, I got the idea that maybe a special radar system was disturbed that is at the heart of modern air traffic control. It's called this secondary radar. It sends out a pulse to an airplane. Black box replies with the position to the ground. Question and answer. So this system is very accurate because the aircraft positions given down are very accurate. And in this case, somehow the solar radio burst impacted the system operation. Here on the right side, you see the dark rectangle. That's a screenshot from the Callisto system. It's a more or less freelance system. It's an association of radio receivers, and that are able to receive solar radio bursts. In this case, we have the frequency range here on the left, 1000 to 1250 megahertz, which is the frequency range of the secondary radar. And we see the time at the bottom, and we see the intensity of the radio burst reflected by the coloring. So where you have the yellow color, high intensity. Don't ask me how high. That's the subject of a research paper from which I have taken the screenshot here on the left. You see little green crosses. They represent aircraft. Now you will say, oh, that's many. Yes, it's too many. The air traffic controllers cannot keep so many crosses apart. And this picture here is actually from a radar scope in Belgium. And I suspect that the situation in Stockholm and in southern Sweden was actually worse. Anyway, the supervisor there decided that flying should cease for 1.5 hours. By the way, I have since obtained similar pictures of air traffic control radar scopes from Norway. I've heard of it, that it looked almost the same in Germany and in Austria. So to call it just the impact on the Swedish system is keeping it small. In fact, a solar radio burst. Next thing, X-ray flare. The X-ray flares from the sun move towards the Earth and go through the ionosphere, which they then, I would say in lay language, they heat it up. They mix it up. And then the ionosphere is no longer capable of reflecting the shortwave radio transmissions from aircraft. They will absorb it. And the impact on aviation, well, you cannot call in the position reports anymore. If there's no radar, then air traffic control works via position reports that aircraft give. They tell air traffic control, we are now at this point, a name, coordinates, at this level, flight level, altitude, and we will have our next point at that time. And if the report is missing, then air traffic control starts to get nervous. And if it's missing for a long time, they will start the search and rescue protocols. They will call for the uncertainty phase or the alert phase, or even the distress phase when it takes too long and it's overdue by too long. In this case, a report was overdue by 90 minutes, as you see on the left, and they started the alert phase. Now, I'd like to introduce a technical system that's a satellite-based augmentation system to GPS navigation. GPS is pretty accurate. but suffers from ionospheric disturbances, scintillation, and others. And clever people have come up with the idea of installing reference stations on the ground, whose position is known. They measure the signal of the GPS, the deviation is being sent to a master station. A correction signal is calculated and sent up via the uplink station to the geostationary satellite. And then from there down to the airplanes. Pretty good system that improves the accuracy and integrity of the navigation signal by a lot. So this system can also be disturbed. It works through the ionosphere, and in this case, the ionosphere disturbed it so much that the American Air Traffic Control Command Center sent out the message that it is unreliable. That means approaches to land using that system couldn't be used anymore. In Europe, we have a similar system. It's not called WAAS, W-A-A-S, like in the US, but called EGNOS. A similar system. We will see what that has as an effect. Here's another case where the American system was impacted. 2017, there was a series of solar flares. Geomagnetic disturbances resulted, and this here is a graphic that shows the service area of that system. Blue is good, red is bad, and as you see, the whole of the United States is not covered anymore. Here's a little triangle cut out. That is the consequence of an ionospheric disturbance. So now we can enjoy a view of the Aurora. I had some of my best moments in flying going north from Europe over Scandinavia and flying actually under these bands towards some point in the north, more northerly, like in like almost close to the North Pole. So then you will see these bands, they are moving, they change color, they change intensity. They are just beautiful to look at, but difficult to capture on camera. We come to the information from the American Space Weather Prediction Center. This is a screenshot. It shows their NOAA scale indications of space weather, of radiation and geomagnetic disturbance. And here on the right, a forecast. A little bit of text, and at the bottom then more information, the sun, coronal mass ejections, auroral forecast. It's more a nowcast, it's valid for the next hour, the record 24 hours back. Beautiful to watch it if you have some activity. And more information from satellites. They also have an aviation page, which shows the space weather effects on shortwave radio here. There is a model that shows the absorption. If there would be an effect, you would see a red dot in the middle or at the polar areas in the north and the south. Here on the right, the proton flux is measured by a GOES satellite. That would be an indication of maybe increased radiation risk if these lines wiggle up. The ESA web page reflects a collection, or is a collection of a lot of research type displays of space weather here available here in Europe. Actually, maybe all of what kind of reliable to put on the web here in Europe. It's a great collection, a bit difficult to navigate through, but on the left side, they have put it together in service domains. And if you're interested in spacecraft design, you get a different set of pictures than here for aviation. In aviation, we have shortwave radio, we have total electron content, and for Europe, and we also have radiation. Radiation dose, well, you can actually calculate it. If you go to that little thing in the ESA web page and call up the full product, you get to the model where you can enter your departure and destination and time. When you want to fly, press calculate and get the effective radiation dose on your flight. Of course, it's done with standard values and may not be accurate, but it's a first indication. It's good for taking a look. There's also a little bit more professional version on this one, so go investigate. Now we have ICAO, International Civil Aviation Organization, Space Weather Advisories. They are, first of these advisories have a rather long history. In the 2010 to 2010 timeframe, there was a cross-polar working group which came together to discuss what could be done, what should be done with regards to space weather. That was then put up to the ICAO level. Proposals were circulated 2014 and on, and the rest is history. I will come to that. Here we have, first of all, something space weather impacts on aviation radiation. When we live here on the ground, we have an atmosphere above us, and that's providing very good shielding against most of the energetic particles radiation from space. However, when you go flying, especially jet airplanes, then you go to 10 kilometers, 12 kilometers, or even higher of altitude, and then the radiation dose that you receive from space weather, from the sun or from the galactic radiation bit, will be higher. Pilots have to live with it, flight attendants too, and passengers too. Guess what? We are all humans, so it affects us all the same. But the more you fly, the more radiation you get. The higher you fly, the more radiation you get. So you have to adjust if you want to avoid a lot of radiation. IFALPA has a publication out on it. You can Google it. Just Google IFALPA radiation and aircrew, and it will come to you. Governments, here we have one more thing from ICAO. They have rules. If you fly higher than 15 kilometers, you need a radiation indicator. That was the Concorde, but today, if you have a lot of money, you get very sleek airplanes that can fly, take you halfway around the world, and they fly or can fly very high, like 51,000 feet. Thus, they also carry this equipment. And then we have Europe, the rules. There are always rules. And in Europe, the Euratom rules and EU directive is in effect. It limits the maximum exposure for everybody, including aviation. And what is something important is for us is that if more than 1 millisievert of radiation per year is expected by the job that you do, an assessment of the amount of radiation is needed, is required. An assessment, so now aviation is actually the highest impact occupation with regards to radiation. You can, there have been statistics have been done, and unless you work in uranium mining, you have a very hard time getting higher radiation values for a group of people like aviation workers. So usual values are around 3 of these millisievert per year, but that will be then communicated to the pilots, to the flight attendants every year by the airlines, and the dose assessment is actually done by a model. There are limits also. I see here 50 millisievert per year. That's a very high number. The national legislation here in Germany, Austria, and maybe also elsewhere limits it to something like 6. And when this is reached, then you need to go to a special medical examination and maybe not fly different routes. Okay, that's about radiation. Now we come to the space weather advisories. Space weather is a very new field. I don't know exactly when it was coined, but I know that it was put together during the period of 2010 to 2018. ICAO has books that are called annexes. They are very highly regarded. It's a complicated process. All governments or states rather that are organized in the United Nations organized sub-organization ICAO have to agree to changes there. And so that's pretty solid stuff. And that's where we have space weather. There are some finer details, a description, values, limit threshold values there in a document that I put here on the right. Now, what do we have in ICAO space weather? We have advisories that will tell about shortwave communication, satellite communication, GNSS, that is Global Navigation Satellite System, is GLONASS from the Russian Federation, or GPS, or the Chinese one, or I think the Japanese and India also have some, and radiation. The scientists among you will be surprised to learn that we have no advisory if conditions are nominal, and only if thresholds are breached, we have advisories that are called moderate and or severe. And pilots don't know the thresholds. They can look them up, yes, but the advisories will just say moderate or severe. You see scratched out satellite communication. Well, there's a high desire for having this, but until now, no one could actually establish a relationship between a space weather effect and satellite communication. So maybe it will become in the future. Here you see the space weather advisory thresholds. We have scintillation for GPS and phase scintillation, the TEC units. We have the radiation effective dose at 30 or 80 of these microsieverts per hour. This may seem a lot or not, yeah, but it has a special feature. The advisories will say that there is moderate radiation above flight level 350, for example, moderate above flight level 350. So if you don't like this, then you just fly in level 300, 300. Then you don't have this moderate radiation. That's how this system works. It will tell you the flight level above which these radiation amounts are reached. It will not tell you the maximum in case you have the severe above level 400. It will not tell you that there is maybe 150 in flight level 420. No, it will just say above. Then we have the shortwave radio impacts listed below. The weather is put together from space weather information by the 4 space weather centers. One is in the US, the Space Weather Prediction Center. In Europe, we have a consortium of the European Space Weather, community, I would say. It's called Pegasus. Then there's a China-Russia consortium, and a 4th one, that's Australia, Canada, France, and Japan as the 4th consortium. And finally, a regional center here in South Africa. These 4 centers work 2 weeks and on and then off a rotating schedule. On the left, you see a web page of the Pegasus Center. Google it. If you click check here, then you get the latest space weather advisories, which look like the ones you see here on the right. I have a better slide that explains it, where I can show it in detail soon. Rules. We have the ICAO rules that are valid basically for the world, but to make it the law, each country has to put the ICAO advisories into its own law. And so 2018, ICAO published Annex 3 space weather. 2019, the center started working. 2021, the European Union signed a directive that the changes in space weather are now European Union law. And this year, in November, EASA put out space weather information in their easy access rules for air traffic management and for air operations. And so we see that pilots have to carry the appropriate meteorological information, which shall comprise weather information, forecasts, and advisories for volcanic ash, tropical cyclone, and space weather. So there is no but or maybe or something. It's a shall, it's compulsory. And it doesn't happen. Big surprise, ICAO put it in the annexes, EU, here our local government put it in the rules, as you saw. But at the beginning of the year, colleagues and I looked around and we couldn't find any space weather advisories. They are available via the weather services, yes, but they are not in the flight documentation for pilots. So we put out a safety bulletin. Recheck just 2 weeks ago, no, it's not there. And I do not know what to do. I do not know how it will go on, but space weather advisories have to go to the pilots. 7th of November this year. Yeah, we have a space weather advisory. It shows the center. That is the Pegasus center. It shows the number, and it shows the space weather effect, GNSS severe. Severe disturbance of GPS. And it's an observation on the 7th at 1517 Z. Z means GMT. H and H stands for high latitude northern hemisphere, and HSH high latitude southern hemisphere, and it's from 105 degrees west to 135 degrees east. Forecasts are not available, and the description is at the bottom that the space weather event is in progress, an ionospheric disturbance, and the impact on GNSS is possibly loss of signals and degradation of timing and positioning performance. So that's what we have. And if you click to a developmental display of Pegasus, you see that this area here is impacted by severe space weather. And that's northern and southern hemisphere. Quite a large area. You may wonder if this is true. This is the Aurora forecast of the Space Weather Prediction Center for the time. And you see enhanced auroras here symbolized by the orange colors. They are reach from Iceland to, well, what's called Alaska, I think. And here we have Scandinavia. If we compare this to the area that the space weather advisory covered, we see that there is, I would say, reasonable agreement. We have Scandinavia here, we have Scandinavia there, and we have Russia here, and we have Russia there, and we have Iceland here and Iceland there to Greenland. So it's a qualitative indication that there is something going on. The European AGNOS system, that is the satellite augmentation system, that's the equivalent of the American VAS around here. issued this advisory. Somehow their availability area is not as it should be. And it is true. This here shows the availability of the EGNOS system for approach and landing. On the right side, you see the normal full extent of coverage. And on the left, you see what it was on the 7th of November. You see that Iceland is not covered anymore and that there is no good coverage over northern Scandinavia. A bit later, Iceland barely gets something, but northern Scandinavia is worse off. So coverage is reduced. And if you remember the little picture that I showed you with the GPS monitoring stations, EGNOS has a rather a big number of them spread out over the whole of Europe, over the area of interest. And this here is from Kirkenes, that is northern Scandinavia. And you see 3 wiggly lines. The bottom line says horizontal position error. That's not so important today. The protection level, horizontal protection level, is a little bit more important because it shows the guaranteed positioning accuracy. And as you see, the values are very high. It's beyond the top of the scale, beyond 50. What is also remarkable is the purple line, number of satellite vehicles in use, and they drop to 0 at times. 0 or 1. So not a good situation. And from a colleague, Mr. Suzumu Saito in Japan, I got the tip to look at the Kyoto index for the Aurora electrojet, which I did. And when I put this Aurora electrojet, is some kind of current flow in the ionosphere in the Aurora region. And it agrees very nicely, timing-wise, with the GPS disturbance here on top. 12 o'clock, and the disturbance, highest disturbance, where we have the highest Aurora electrojet. Now that was the European situation. Let's move to the other side of the Atlantic. 1736, trouble starts in Canada, manifests itself a few hours later, and is there in the end, and then this effect vanishes. So what should a pilot do with this? Fly or no fly? What do we do? Let's examine this shortly. If you are interested in more scientific discussion of the space weather effects of 7th of November, I recommend this STCE newsletter, which describes GNSS a bit in trouble. Flying, let's go flying. Flying is teamwork. So there has to be some rules, there has to be a book. That's the operations manual that describes how operations are being conducted. Unfortunately, space weather is not in the book, but let's go flying anyway. We have dispatchers, people in the room that compile all the information that a pilot needs to make for a flight. Always changes, the weather changes, the routes change, and also what is maybe broken in an airplane changes, or not airports or so. And that would be a set of information, flight plans, weather, the notices to airmen that tell you that the runway is under repair or something like that, and weather charts. And here is the place for space weather, or would be. So this flight crew has the space weather, GNSS severe. And should they fly now or not? They also know that their destination is Akureyri. What do you think of this? Well, depends on what they do. They intend to land using this approach, this APV-1 approach. And so here is Akureyri Airport at the bottom, and the approach is over water along a fjord. There are high mountains, left or right, 1,000 meters. And so you descend into the fjord, and at the end you hopefully see the runway, then you can land. And if not, then you have to go around. And on the right side, you see a tabulation of numbers. This is the lowest altitude you can descend to if your approach guidance system is working. And you see 640 for LPV, 940 for the next best, and 1210 for the most coarse option of a landing guidance. So if LPV does not work, what then? Now let's see the coverage area. Here's a nice graphic from EGNOS, which shows the coverage area, and it shows airports where this LPV works in green and some in red. What does the red mean? You click on the airport, APV1 not available. This on the left, good situation, it's available. On the right, not available. So you have to make something up, and that's not good. You need to have this information before the flight. Then you can plan, fly to another airport, make sure another approach facility is working, or that the weather is good enough. What you saw until now is, well, you could say it's amateur work, but there's also the professional way of looking at it. Eurocontrol, that is the European agency that oversees flight operations here in Europe on behalf of the EU. They have studied this subject, and if GPS doesn't work anymore, the stuff that is scratched out is no more available. Navigation, surveillance, communication doesn't work because the data links, they need exact timing, doesn't work anymore. And so basically, bottom line, the tight traffic flow, tight distances are no longer possible, reduced capacity. And for you as a passenger or my colleagues in the cockpit, it means delay. You sit and don't get the okay to fly. What to do? I mentioned that space weather advisories are not in the book. They should be. And if you click to the European Cockpit Association, ECA, and Google for space weather advisories in the ops manual, you get to this little piece that describes some first ideas drawn up by colleagues and me on how to handle the ICAO space weather advisories. That's close to the end. The conclusions: we have space weather that can impact aviation severely. We have useful information sources in the American Space Weather Prediction Center, the ESA SSA webpage. But of course, there are also others. I'm aware that there is this ICES group of space weather, well, let's call it observatories. And finally, the ICAO space weather advisories, yes, they are there. They have a role to play, they are helpful, but they need to be integrated in flight operations. No good if Pegasus and the other centers put out advisories that pilots do not get. And with that, I'm at the end of my presentation for today. And I will, of course, stay online so we can have some questions maybe.
Thank you very much, Klaus, for this well, very fascinating inside story. I think I was really glad to have someone who can bring this up as a user and bring his own view, which is not always the same as the one we have as a scientist. So thank you for that. I would just like to mention that the webinar that will be given on February 2nd will be given by Norbert Jakowski from Germany, and he will focus on the issue of radio communications, also GNSS and so on.
Thank you.
That being said, I think now is the time for having questions. So there are already 2 questions. If you do have questions, don't hesitate to write them down in the chat. Any question is welcome. So let's start with the first one by Lorenzo Rimordini. And he's asking if space satellites are affected by space weather. They could be temporarily out of order. Does it also mean that they could provide, excuse me, return incorrect information?
I would say yes, but I have no example and no technical knowledge about this. I don't know.
Okay, so maybe this is something we can ask.
I would not rule it out. You have to ask a specialist for that.
Yes, okay. So there was a question by William Wall, who actually found in the meantime a piece of answer. It says, have there been studies of aircraft crews to see if they have higher rates of cancer than those who don't fly much? And he mentions the document that. So
yes,
is this some?
Yes, there have been studies. There have been numerous studies, and they have all been done in the past. And that's when flight crews did not get as much radiation as they do today. You know, there's always design drive to get aircraft more efficient, to make them use less fuel, and for this reason, well, the aircraft engines have been improved, the airframes have been improved, the aerodynamics has improved, and it means that today's airplanes fly 3,000, 4,000 feet higher during a normal flight than airplanes used to fly during the times when the studies were done, and that means an increase of maybe 30% or more of radiation. And so I think the studies have been inconclusive so far, maybe a little tendency to higher risk, but it's a difficult subject. I don't know.
Okay. I remember there were also issues with European regulations regarding pregnant women who could exceed the allowed dose during those flights.
Oh yes, oh yes. Pregnant women are allowed to fly in America, in the US, for as a job, as a pilot or flight attendant. I think not so much here in Europe, but of course, pregnant women fly because they wanna have a vacation, they wanna visit someone, they have a reason to go, just like everybody else. And that was actually one of the drivers for the radiation limits that when we set them at the ICAO match panel. We thought of a long-range flight, 8, 9, 10 hours duration. So the limit is that the dose is not exceeded that pregnant women can get. And that's why we came to these values for the severe value.
Okay. So here we have a question by Mike Hepgood about severe events. So are there any plans to exercise how space weather advisories would work in practice, not least to check if everyone can keep up when space weather changes rapidly during a severe event? That's a critical issue.
Well, that's actually a very good question. Colleagues and I have proposed it to ICAO groups here in Europe and also to Eurocontrol. And I'm happy to report that the response has been positive. It has been taken up. It has not been decided that they will take place on the 15th of June this next year, but people are thinking of it, people are talking of it, and there will be space weather exercises on a larger scale, yes.
Okay. So another question by Hans Zinnecker. On the ICAO space weather advisories for geograph, I noticed that South America is not included. Why is this so?
I'm not aware of not included of South America. Which one was that one? Let's see. This one maybe? Well, it is just because there is no regional center or no center being established here in South America. There was, when the centers were being founded, there was a very wide-ranging questionnaire sent out to the institutions that could possibly do it. I think ISIS is the word for that, the association, and some responded and some said no. I'm aware that there is space weather being done in South America, in Brazil, for instance, but they have space weather. They get it, I think, every evening. They have scintillation there, but not to worry about South America. The other space weather centers, they have data. They will do forecasts. They will do advisories for the whole world. And so that includes South America.
Okay. So by the way, Mihai Codescu made a comment, and he said indeed that ICAO space weather advisories are global and no regions are excluded. So some regions may not have measurements necessary to support advisories. So okay, it's definitely global.
Yes.
I had a question from my side is, how about solar proton events? They are quite rare, especially those that penetrate deep into the atmosphere that lead to so-called ground level enhancements. Have you ever encountered these? If there is one in progress, what kind of warning can be issued? Is this taken seriously, or is it just considered as too rare event to be taken into account?
Well, the last one was 2017, and that's when I sat in the car on the Autobahn. So I was just checking my emails, and there was one from the center in Greece, an advisory that something was going on. But that's not what pilots do. Pilots depend on the ICAO space weather advisories for the simple reason that they need to be notified. Only ICAO advisories have access to the communications channels are being spread around the world in a way that makes it possible that pilots get them at all. So if something happens like that, I would hope that it comes to the cockpit. At the moment, I'm highly doubtful of it because it's not in the flight preparation documentation, but it should be there. The system is designed that it will be delivered to the cockpit.
Okay. And what is then the mitigation measure you can take? Is to lower the altitude?
Well, first of all, I gave you the link to the European Cockpit Association, the thoughts that we had there. Where are they? No, I don't see it here. Well, yes. Basically, you need more protection, so you try to descend. What you do is that you put out a request to air traffic control and tell them, guys, I need to descend. I request a lower level, whatever.
Okay.
And but you only do it after checking the whole situation. Like, do I have fuel to continue to the destination, or do I need to divert to another airport? It's or should I even do it, or should I do nothing? Just doing what I've often heard is what happens if it's severe and everybody tries to descend right now. Well, sorry, that's not a good option. Because air traffic control cannot handle it if everybody wants to descend right now. And they are just mixed up in the lower airspace, and the collision risk increases. And other risk also, like that you run out of fuel. And so if you descend right now, it can take away 30 or 40 or 50 years of your life expectancy in that moment. And radiation might take away 1 or 2 years. So please stay calm, drink another coffee, and think it through before you do any action.
Okay. And by the way, Ludwig Klein mentions that the last particle event that had a significant radiation dose associated with it, more than 30% of the galactic rate, was in December 2006, and the 2017 event was minor.
Yes, it was minor. 2017, 2006 was more. So I would say the clock is ticking. We are due for something.
Okay.
We have not had a good space weather event, a real strong one, in quite a few decades.
So for all the attendees, just we were about to start, Klaus mentioned an interesting event, which is the risk associated with major debris falling into the atmosphere. I thought it would be interesting to bring it up. If you could just recall that story you mentioned at the beginning, Klaus.
Oh, sure. Oh,
Of
sure.
the Chinese, yeah.
That was really interesting. So the Chinese launched another part for their space station, and I think it was the second stage of their rocket. Well, it reached orbit, but not for long, and then it drifted down, and at some point re-entry was due. The Europeans made their calculations. ESA did it, I think, on behalf of the European Air Safety Agency, and they said that it will come down at this time exactly to the minute, and uncertainty range plus minus, I think it was 30 minutes or 40, I don't know. And this point where it would come down happened to be somewhere in Spanish airspace, and based on this advisory, the Spanish civil aviation authorities actually closed the airspace for flying. So airplanes had to stay on the ground, I think, for 1.5 hours until everything was cleared up again. Or was it 1 hour? I'm not sure. And I think also France was affected. And I do not really think that that was the best response possible, because if the uncertainty range is half an hour at orbital speeds, that's 1/3 or 1/2 of an orbit. So it could have come down between South America and China, basically, somewhere. And yeah, would you want to stop all flying? I also checked another forecast that's from the aerospace company in the US, and they had a bit later entry, 2 hours behind the Europeans, I think, and had an uncertainty range of 3 hours plus minus. And so that's 2 orbits, and if you have these uncertainties, what can you do? There's so much debris is not good. Has to be deorbited in a controlled way so that it comes down somewhere where you know it doesn't do harm. Yeah, that's what I think. My personal opinion.
I had another quick questions, if there are no more at this stage, regarding avionics. When there are particle events, the impact on avionics and errors with onboard computers, I guess this has been documented. How serious an issue is it?
It has not been documented because the yellow colored protons with the red dots on it that did it is gone. Okay, so only thing that you can write down is that one system did not work and that you switch to the next one. There are maybe 2 autopilots or 3, and so they will continue to work and work and work forever until once in, I don't know how many thousand hours, they will just don't work anymore. And so you write it, you recognize it, you deal with it, you establish a safe flight condition. Probably nothing will happen. You just press another button, another autopilot works, and that's it. And so then you write it down, and many times I've read up on it in magazines dealing with aircraft maintenance. Many times then the black box that was responsible just gets tested on the ground. If no fault is found, it's okay, go fly again. And if it gets removed, it's sent to the factory center that looks it over and finds no fault, then it goes also flying again. It's extremely difficult to find single event effects and prove it. There is no database for that, to my knowledge.
Okay, yeah, I see. So there's another question by Lorenzo Rimoldini. Would solar power from space beamed to Earth in form of microwave create zones to avoid?
I would say so. At first hand, I would say I would even require a large safety zone around it, because when the satellite beams it down, who says that it just beams it down like this? You know, we were dealing with faults induced by space weather, and maybe the satellite has a a faulty gyroscope or whatever, and wiggles a little bit, and the beam on Earth moves 100 kilometers or 2. I don't know what they do. Needs to be studied.
Yeah. First, you need to build a system.
That's a minor matter for the engineers.
Yeah.
They can do it.
So I think we are getting close to the end of the questions. So I think we'll probably close this webinar here. Again, I would like to thank you very much, Klaus, for preparing this talk, for accepting to give it, and for sharing the inside story. For attendees, I just want to mention that, as I told, on February 2nd, there will be a webinar by Norbert Jakowski on radio communications GNSS, and January 19th, Ilko Doornbos will address the issues with debris. And our first webinar of the next year will be, or the next one actually, will be given by Jean Lindsten on the Aurora activity. So with that, many thanks for attending. And of course, you're always welcome to attend and to listen to the next webinars. After this series over, there will be another one on other topics which are related to AC activities. So thanks to all, and have a good vacation, and see you next year, hopefully. Bye-bye.
Bye-bye.